Welcome back, learners. As you know, in the previous lecture we were discussing about the design of the columns. So for the problem that what we have considered, we have completely finished the design of the columns. And you know, when we were doing the design of columns, we have designed it as an uniaxial loaded column. That means the column will be having the axial load and the column will be having the one moment. So before I move on to the next step of this problem, I would like to explain you brief about how to do the design of the axially loaded column as well as how to do the design of the biaxially loaded column. Anyhow, the PDF of the axially loaded column design and the biaxially loaded column design I am going to share in the platform. But anyhow, today I will explain you that how the major difference that you are going to get in the uniaxially loaded, because the design what we have done in the column was by considering as an uniaxially loaded column, that is axial load and one moment, and the one moment that what we have taken is the higher value of the moment. Now in case if I am going for the biaxial loaded column, then so this entire procedure will be same. Anyhow, I will be uploading the same kind of PDF in the next video, making this as a biaxial loaded column. So the grade of concrete we itself have to decide, and that will be an input value, and the shorter dimension of the column will be decided by us, that will be an input value. The longer dimension of the column will be decided by us, and that will be an input value. Then the axial load on the column, that will be an input value, and that value, as you know, we are going to get from the software analysis. Okay, so once the software analysis was carried out, so from that you are going to get the axial load. After that, you can see that we have another option called as moment at the base of the column. Okay, moment at the base of the column. So now here, this moment at the base of the column is also an input value here only, here also. But the difference is when I am doing the axially loaded column, this part will not come into picture. That is, there will not be any moment at the base of the column. Okay, that is when I am doing axially loaded, as the name itself indicates. So that will be only for the axial load, that's all, only the load, axial load, no moments will come at the picture. But since the previous design was done by considering it as an uniaxial loaded, there will be one load we are going to consider. Okay, there will be one load that we are going to consider, one load we are going to consider, and along with that one load there will be one moment. Okay, there will be one moment out of the moment along x and out of the moment along y. Okay, out of the moment along x and out of the moment along y. So we will be consider the one with the highest moment. Okay, we will be considering the one with the highest moment. Okay, we will be considering the one with the highest moment. That is how we have done the design of the uniaxial loaded column. But when it comes to biaxial loaded column, this moment at the base will be taken as 2. Okay, this moment at the base will be taken as 2 moments. So one will be the moment along the x direction and one will be the moment along the y direction. Okay, so one will be the moment along the x direction, one will be the moment along the y direction, right? Yes, so therefore here this moment at the base of the column will be 2 values. Okay, one will be x, that is we can say moment along x, that is mux, and one more will be moment along y, that can be considered as MUY. So those two inputs value also we are going to get from the analysis part. Okay, those two values also we are going to get from the analysis part. So therefore when we are going to design the column, okay, when we are going to design the column as the biaxially loaded column, then you will be having the three parameters. One is moment of the column in x direction, moment of the column in y direction, and axial load. Whereas when you have uniaxial load, uniaxially designed column, then you will be having the axial load, and out of the two moments whichever is higher, that we are going to consider. And when you have only axially loaded column, then you will be having only axial load. So now therefore according to that, the next step anyhow it will be effective cover, that will be d dash, that will be an input value we are going to consider. Then anyhow as usual we will find out d dash by d value. Okay, we will find out d dash by d value. So that will be effective cover by longer or shorter dimension of the column, as we already discussed, based on along which dimension the column is going to bend. So based on that it will be longer or shorter. Then now instead of having only mu, as I already told, you will be having two values. So one will be mu x divided by fck bd square, another one will be mu y by fck bd square, and another one will be pu by fck bd. So these three we are going to consider. That I will explain you in the chart. So from the chart we are going to get again p by fck value only. After getting p by fck, so we are going to get the percentage of steel. Okay, so once you get the percentage of steel, from the percentage of steel you will anyhow you will calculate area of the steel. So once you get area of the steel, you will decide the diameter of the reinforcement that you want to apply for the column. So then you are going to consider the area of the one reinforcement, and finally you will calculate the total number of rods required. Okay, then when it comes to the lateral ties, you should have the diameter of the lateral ties that you are going to provide. Then finally you will find out the lateral tie spacing, that is least lateral dimension, 16 times the dia of the main rod, 48 times the dia of the lateral ties reinforcement, 300 mm, out of which whichever is least, that you are going to consider. So in this way all those remaining steps will remain as it is. The only change is, instead of having only pu by fck bd, along with it you will be having mu x by fck bd and mu y by fck bd. That is how the difference that you are going to have in the biaxially loaded column. Okay, yes. Now according to that, you can see here, if I am going to do the design as per the biaxial loaded column, I will show you. You can see that these are the one with uniaxial loaded column. You can see that we have used this pu by fck bd, mu by fck bd. In case if you are going to have the biaxially loaded column, okay, if you are in case you are going to have the biaxially loaded column, yeah, then I think it is top. Just a minute, I will show you. Yes, you can see here. No, not this one. Just give me a minute, I'll be searching. See, these are all for the charts that we have already used. Okay, that is your uniaxially loaded columns, PU by FCKBD and MU by FCKBD. Just searching that where it went. Somewhere it is there. Yeah, you can see this one. This is the one that we are supposed to use for the biaxial bending. Okay, you can see that there is an chart what we call please remember this chart number 64, that is biaxial bending in the compression member, right? So how you are going to get this? You can see here it is MUY by MUY1 and MUX by MUX1. Okay, so this value you are going to get, and this is PU by PUZ value. Okay, right? So in detail that let us see when we take up the design of the biaxially loaded column. Okay, as of now no need to worry. So because in this problem we have completely designed it as an uniaxially loaded column. So when we come to the biaxially loaded column, so we are going to learn how to do the design of the biaxially loaded columns. Okay, so as of now no need to worry. But before we go to the next step, that is nothing but the design of your beams, I would like to explain you some important points that you should know that while doing the design. Okay, so what is that? I just wanted to tell you. See, usually whenever we do any designs of columns, most of the people, they have a confusion that whether our column should be designed as uniaxially loaded, or our column should be designed as biaxially loaded, or our column should be designed as axially loaded columns. So that kind of doubts usually it will be there. Now in order to do that, I'll just tell you, I'll make you very clear that usually let us consider one basic plan. Okay, I'm going to consider one basic plan like this. Or let me consider one yes, so let us consider one plan like this. Okay, so then let us assume that, so these are my center lines. Okay, just assume these are my center lines like this, and even let us assume that, so this is my center lines. Okay, now let us consider the columns in the center like this. Here one column, here, 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 here. So let us consider the columns like this. Okay, so here also let us consider. Okay, I'm just randomly showing the column positions, that's all. Now whenever we have like this, usually the columns which are present at the borders, you can see the columns which are present at the borders. So those columns usually they will be subjected to the biaxial loaded columns. Okay, the columns which are present at the borders usually they are subjected, or I can say the columns which are present here, the columns which are present here, I can say these columns, like for example if I fill this you can able to understand. So this columns, okay, so these columns, okay, so these columns usually they are subjected to what we call it as uniaxially loaded columns. We can design them as uniaxial loaded columns. You may have the question why they can be designed as uniaxial loaded columns, right? Because you can see as to learners, what will happen is usually the moment which is going to develop in this will be nullified by this part. Similarly, the moment developed here will be nullified by this part. Similarly, the moment developed here will be nullified by this part, this beam. The moment developed here will be nullified by this. But you can see that the moment developed here will not be nullified by any beams present, because you don't have any beams here. Therefore, it will be having axial load and it will be having one moment. So therefore, these columns which are made it in black color, approximately we always design them as a uniaxially loaded column. Okay, that means one axial load and one moment. Now if I take this one now, okay, if I take this one now, you can see that which are in red color. Okay, if I take this one now, so this we have to design it as biaxial loaded column. Why biaxial loaded? Because you can see the moment developed here, we don't have any beam on the other side to nullify them. So therefore that moment will come to this column. Similarly, the moment developed here will not have any other moment to be nullified in this part. Okay, so therefore the moment, that moment also will come here. Therefore that means the corner columns, you can see here these corner columns, usually we are supposed to design them as the biaxially loaded column. That is one load, that is one axial load and two moments. One axial load and two moments. Okay. Whereas the columns which are present in the center, okay, like I can say these columns, I have an option to design them as the axially loaded columns. Okay, I cannot say all columns I can, without any checking I can go for axially loaded. No, it is not possible, but to some extent I can design them as axially loaded, because what will happen if the lengths of the beams are same or the spanning of the beams are same, then what will happen, whatever the moment developed by this column, that will be nullified by this. Similarly, moment developed by this will be nullified by this. Similarly, this will be nullified by this, like this. So every beam, alternate beams will be there, no? So they nullify each other and the moment at that column will be very less, or it may be almost equal to 0. Therefore, I can design them only as the axially loaded column. Okay, but keep it in mind, learners, whenever we do that, we have to check and we are supposed to do. Now, according to that, let us check that now what will going to happen for this. Okay, so for that, first what I will do is I will download the column values. Okay, I will download the column values now. So I will go to display, I will go to show tables, right? I will go to analysis. I need the column values, that is forces. So I will go to the results. In the results, I will go to the this is an frame results. In the frame results, I need column forces. I will give OK. Right? Yes. So now I'll just open one Excel sheet. Yeah, I'll just paste it here. In that we don't want any V3, V2 and T, so therefore I'll delete them. Okay, so I'll apply filter for this, and what I'll do, I'll check only the combination of dead load and live load, and I'll go for the last story, that is story number 3, and I'll go to the value of that 0. Okay, sorry, I'll go to the value of this 4. Right, I need only 4. Okay, yes. Now if you take this, now you can see here that these are the column numbers. Now you can check with that. Now I'll unlock and let us go from column number 1. Now my first column number 1 is present here, and I have gone for story 3. Okay, yes, so this is my story number 3, right? Okay, so now if you see this, the first is story number 3. Anyhow axial load is present. You can see that there is both the moments M2 as well as M3. Okay, so both the moments are present, that is M2 as well as M3. That means the moment is present along both X as well as Y direction. The reason is, you can see that the column 1, it is a corner column. So the moment developed by this beam, you don't have any other option to nullify on the other side. Even B5, you don't have any other option to nullify here. So definitely this, since it is a corner column, it will be having the both the moments significant moments will be present. Therefore for the column 1, you can see that both the moments are significant. What about column 2? What about column 2? The column 2 is this one, even that is also, it is a corner column. So therefore both the moments are significant in nature. You can see that column 2 also, both the moments are significant in nature, right? Yes. Then what about next you have is column number 3. Where is column number 3? Now you can see column number 3, the moment developed by the B5, that is beam number 5, will be somewhat nullified by the moment developed by the beam number 15. But since there is nothing on the right side of this column, whatever the moment developed in B6 has to come. Therefore you can see that any one moment will be very highly significant along with the axial load. Okay, that means the moment along this direction, that is which direction? I think it is which is that axis, this axis. Yes, that is X axis, that is moment along X will be significant here. The moment along X will be significant here. You can see column number 3. If I go to column number 3, you can see here that moment along X is significant. Y is, you can see it is very less. Okay, it is very less. So therefore that time you can develop that column number 3 as biaxially loaded column. So since the problem that we have taken was a very first problem, so I didn't design the column separately. So when we go up with the next problem, so definitely we will design each and every column by looking like this, biaxial or uniaxial or axial. Okay, but as of now in this problem, since it is a first problem, I have designed all the columns as the uniaxially loaded column, that is one moment, that is highest moment, and one load. So like this we will do for the next problem. So therefore I can write that this, I can design it as biaxially, I can write biaxial loaded. Okay, so I can write BI. This also I am supposed to design it as BI. So this I can design it as uniaxial, I can write UI. Okay, or I can write BA, biaxial, and this is uniaxial. Okay, yes, that is column number 3. So the next you are going to have is column number 4. Let us see where is column number 4. Yes, column number 4. You can see that column number 4 is also, it is a corner column. Okay, so definitely we have to design it as an biaxial only, because both the moments will be significant in nature. Okay, you can see column number 4 also, both the moments are significant in nature. So therefore I am supposed to design it as biaxial. Okay, yes. So next you have is column number 5. So column number 5. So definitely it is a corner column. Both the loads are significant in nature. So I am supposed to design it as an biaxial loaded column only. Okay. So like this, in the next problem, let us design that each and every column significantly. The next you have is column number 6. Column number 6, yes, you can see that column number 6 somewhat you can design it as an uniaxial loaded, because this beam and this beam, see, they are going to nullify the moments by themselves. So therefore along x direction you will be having a very high moment, along y direction it will be very less. That is column number 6, you can see. But since the spans are very large here, okay, compared to B21, the B9 is very large. The moments are not much reduced. Okay, because you can see this entire load of this area will be coming to this beam. Okay, so therefore definitely the moment developed at this beam will be very higher compared to this, because this, when it comes to this area load will transfer to here also, here also, here also, here also. Therefore the moment from this side will be less, the moment from this side will be high. So therefore not much difference will be there. So therefore you can see the moment along x and y, there is no much difference. You can see it is 50, it is 80. Okay, you can design them as biaxial only. Okay, you can design them as biaxial only. Then what about column number 7? Column number 7, yes, you can see column number 7. So you can see that this and this almost they are same, and the area by which they are going to receive the load is almost same. So therefore there will be a very low value in this direction and a very high value in this direction. That is, y will be very high, x will be very low. That is, mx will be very low. You can see the mx is very low, my is very high. That means I can design him as uniaxial. Okay, the next you have is column number 8. Column number 8. By looking into this, I can say that I can able to design it as uniaxial, but still, since this area is very high, as well as this entire area is also very high, so this entire load will transfer to this beam and this will come here. So therefore what will happen, you cannot have the maximum nullify in the moment in B11 and B14 beams. Therefore I think we have supposed to design it as an biaxial loaded column only. Yes, you can see here there is no much, that means any of the moments are not almost very less, they are of high significant value. So therefore we are going to design it as an biaxial column only. And what about column number 10? Column number 10. Yes, column number 10, definitely it is a corner column. We are supposed to design it as an biaxial column only. Okay, so it is biaxial. Then what about column number 11? Where is column number 11? Column number 11. Yes, column 11, definitely again corner column. Without fail we are supposed to design it as an biaxial loaded column. Corner 11, biaxial loaded. Then next you have column number 13, sorry, column number 12. Where is column number 12? Yes, column number 12. Yes, column number 12. Even though that you can see that you can looks like you can design it as an axially loaded column, uni-axially loaded column. So we have to suppose to do it as the biaxially loaded column. The reason is you can see that anyhow the moment developed by this column and this column, they are going to nullify, but the moment developed by this beam will be very, very significant, because this entire area, which is of almost how much length of almost so almost 30 feet beam, so that much area will come to this only, this beam. So therefore it is very significant in nature. We are supposed to design it as the biaxially loaded column to be on safer side. Okay, you can see that the moments are very significant. Okay, especially you can see that one with y direction, that is this direction, it is very, very significant. So therefore we are going to design it as the biaxial column only. And what about column 13? Column 13, where is column 13? Yes, column 13 also, what we can do, compared to this, the load is very high here. So either you can go for the biaxial loading if in case the moment from these two, that is B26 and B27 beams, are very less, like within an order of 10, 20, 30, then you can go for the uni-axial, that is axial load and this moment. If these two moments are also very significant, then you have to go for biaxial. You can see that is along y it is very high, along x is very less, therefore I can go for uni-axial. Okay, I can go for uni-axial. Then next you have is column number 16. Column number 16, which is column number 16. Okay, column number 16. Yes, you can go for almost the uni-axial only, because these lengths are almost same and the area is also almost same. So therefore this will almost, it will be nullified. Okay, so therefore you can go for the uni-axial only. You can see that the difference of along x and y, they are not much, so therefore I can go for uni-axial. Then next you have is column number 17. Column number 17, definitely I have to go for biaxial because it is a corner column. So biaxial, without any second thought, all the corner columns has to be designed as biaxial. And what about column number 18? Column number 18, you definitely do it as biaxial. And what about column number 19? Column number 19, yes, better you go for the biaxial, because you can see that the length of this beam is very higher when compared to this. So therefore better we go for the biaxial only. You can see that you can go for biaxial column. Okay, then column number 20. Column number 20, biaxial, it is a corner column. Even though the staircase is present, 20 as well as 21, both we are supposed to go for biaxial. Okay, biaxial, 20 as well as 21, both will be biaxial. And 24, column number 24, you can go for uni-axial, no issues. You can go for uni-axial, almost same are there, you can go for uni-axial. Okay, and what about 25? Column number 25, yeah, that can also, you can go for uniaxial. You can go for uniaxial. Okay, then 27 and 28, you can see this is 27, 28. 28 you are supposed to go for the biaxial. 27 you can go for uniaxial. Okay, so 27 you can go for uniaxial. This has to be biaxial, right? In this way you can able to decide that whether I have to go for the uniaxial, biaxial or axial. Usually until and unless the structure is exactly symmetrical in nature, that means if the column spacings are identical exactly for each spans, if you are having the columns along x and y, then only we can have an axially loaded column. But in practical cases, so if there are more uncertainties or more unsymmetricals in the plan, definitely getting an axially loaded column is difficult. We always go for either uniaxial or we go for the biaxial. If you are designing the column for an axial load, the percentage of steel will be less. If the same column, if you are designing for the uniaxial, then the percentage of steel will increase. If the same column, if you are designing for the biaxial, then again the percentage of steel will increase. Okay, so when we take up the next problem, so let us try to design all three kinds of columns, and in this problem we have designed everything as the uniaxial loaded column. So now we have completed the design of the columns. So in the next lecture, let us learn that how to do the design in the ETABS, and let us go to the design of the beams. Thank you, learners.